So we continue with today's lesson, and now we look at another building component, beams. So in building construction, a beam is a horizontal member spanning an opening and carrying a load that may be a brick or stone wall above the opening. So for example, what we may be talking about would be um, column type structures that would be horizontal overhead, holding up a roof, for example, or a ceiling. Um, and these structures would be connected to the wall, they would be anchored to the wall. So the load may be a floor, for example, or a roof in the building. And this is what we call a roof, we call it a floor joist or a roof joist. Beams may be made of wood, steel, or other types of metals. So here are some examples of different types of beams. For example, here we see an example of a cantilever type beam where we find the beam is anchored to one side, so it's probably a wall. We don't see an anchor on the other side. Here we see the beam is not actually anchored, but it's actually supported by another structure from underneath. Similarly, we find, so the overhanging beam is very similar to that of the simply supported beam. Here, for example, we see the beam is fixed on both ends. Again, usually it would be anchored to the walls on either side. So the purpose of this is really just to give you an idea of some of the different types of beams that we have. It's not for you really to memorize and try to remember precisely what types of beams we have, what they look like, what the structure is like. I essentially need you to just understand what the purpose of the beam is. But I'm just trying to help you make that visual connection as to what these beams are. Then we have framing. So framing in instruction is the fitting together of pieces to give a structure, support, and shape. Framing materials are usually wood, engineered wood, or structural steel. So, for example, I think I may have mentioned it in a previous slide. Types of frames. For example, we have heavy frame construction that would be used, for example, for larger buildings. Some of those steel structures we can see on the outside of the building. When the building is going up, you find that there would be like a metal frame, for example. Smaller buildings you will find would tend to use smaller frames and lighter frames, and some of those smaller frames may actually be made of wood. So if you can think of and imagine, the scaffolding frames that they will put up, these are some of the frames that I'm talking about. Then we have types of ceiling. Ceiling materials become in different types. For example, there will be wooden ceilings. Then there's plaster and plaster board. So traditional material, plaster or plasterboard is traditional material used for covering a ceiling, and for centuries they have used that. It creates a smooth, hard, attractive finish that can actually be easily decorated with paints or even more plaster. Um, Plaster board is similar to that of the plaster, except that it's essentially prefabricated. Um, it's also cheaper and easier to install. Ceilings can also be made up of metal. In particular, for example, some aspects of the metal inclusion in ceiling would be for drop ceilings. So where you may have tile ceilings, for example, your tiles can be made up of all types of materials. You will have usually a metal grid upon which you would secure the ceiling tiles. And usually this type of ceiling, um, facilitated by the metal grid, it will often hide unattractive features in your ceilings, such as pipes, wires, etc. It also helps to control noise, for example, in offices, etc. All right. The tiles, we can have different types of ceiling tiles. For example, they could be plastics. There are a lot of PVC ceiling tiles available now. There's metal, fiberglass. Fiberglass was commonly used before. There's also mineral fiber, wood, um, vinyl, coated gypsum, and even cork. All right. So most tiles are designed for insulation in the suspended ceiling system, and the tiles are often designed to control noise levels in rooms. Then there's also flooring materials, different types of flooring materials. Um, for example, we have a list here: cement, lime concrete, cement or lime concrete, bricks, flagstones, marble, glass, plastic, mud, modern muram, wood, cork, linoleum, asphalt, and rubber. For example, concrete is the most commonly used flooring material. It is suitable for any type of construction and is cheaper than others and durable. Bricks can also be used for flooring purposes, but they're not suitable materials for residential or public buildings. They tend to be more suitable for outdoor rooms, courtyards, etc. So that's where you may have like decorative bricks, etc. Marble has also been used for flooring. Marble is a type of metamorphic rock. Um, it would also tend to be very expensive as well, and it's used widely for floorings in commercial buildings, kitchens, bathrooms, etc. They are stain proof and it's very easy to clean. Um, then for floorings, you would also have ceramic tiles that can be available. These are inorganic materials and possess properties like good compressive resistance. So it can take weight. Um, it's brittle. It's not that brittle, and it's very hard. So we also have examples of wood or timber for flooring, one of the most common methods of flooring. It is preferred when timber is cheaply available, such as in hilly areas. Timber blocks or timber boards are provided as flooring covers, right? So, for example, typically they would be used, wooden floors would be used on dance floors, auditorium, etc. But where you use wooden floor coverings, you need to be concerned about moisture. So you need to prepare to treat the material, the wooden material, with a course of damp proofing. So that's a treatment that will be used to seal off the material from moisture penetrating the material, which would encourage the buildup of mold, etc. There's also linoleum. This is a product obtained by oxidizing linseed oil. Okay, linoleum is something that you all should be familiar with. It's a common floor covering as well. Um, in decades gone by, it was probably more commonly used, but they're available in sheets, and it's almost like an alternative covering to carpeting, for example. Um, but it's easier to clean. It's more plastic type in nature, and there can be some very attractive ones as well. Okay, so now let's talk about some of the health issues associated with building materials. So building materials used in construction of building structures can welcome health issues subsequently for different groups of people. In particular, note this: occupants of the building and workmen. Workmen in particular would be involved in the servicing of the building, such as the construction of the building, maintenance of the building, demolition and refurbishing. So we have occupants who would be more long term, and then we have workmen that would be more short term. All right. And both groups can actually be faced with health issues related to the building materials. So, what are some of the health effects associated with the building materials? We're looking at noise, um, poor acoustic characteristics, dysfunctional lighting, extremes of humidity, inadequate airflow, toxicity of material that is transferred through the soil. Now, if your foundation and flooring is not, you haven't appropriately chosen types of materials to seal off that passageway or that pathway for toxicity from the soil, we can also have a problem, because in some parts of the world, hilly areas or certain types of soil can release radon gas, for example, and long-term exposure to radon gas, research has been showing that it can actually um, increase risk for cancer. So all of these things you would have to be careful about. So these different issues will affect the durability of the building along with the health and comfort of the people residing or even working within the building itself. Materials conversion stage, such as mining of materials, the manufacturing of the materials, whether you're manufacturing cement or processing the lumber into wooden planks, etc., quarrying, as well as the handling of the material, transportation of the material, and the construction processes itself can actually have health effects. So, for example, for workmen, exposure to some of these materials, stone can generate dust, which can be inhaled. Higher exposure to this dust will cause silicosis, which is a thickening and scarring of the lungs by inhalation. Excessive inhalation of the stone dust results in increased risk of lung cancer. Then if you look at concrete, excessive exposure of workmen can result in irritation, um, and they can become more sensitive to the forms of cement and the additives used in the cement. Okay, then there's exposure to asbestos. So these materials were a concern behind the risk of asbestosis, lung cancer, and mesothelioma. So many new materials um, out of cement and polymer matrix, different types of plastics, were developed to mitigate this problem and to replace the asbestos material, so it's not used as much. Then there's exposure to lead. So, so this was commonly used in the old days. Adults would intake the lead through drinking water, while children would intake it through licking the wall with the paint, chewing on paintwork, and even house dust. So this resulted in problems like paralysis, anemia, malaise, or a general feeling of being unwell, severe colic, convulsion, etc. And these circumstances brought about a decision on the replacement of lead as a construction material, so it's not used as much anymore. Then there's cadmium, exposure to cadmium. So this is used to coat steel, and we know steel is very commonly used in the construction of buildings. And this coating is used to act as a protection against the corrosion of the steel. So this protective layer brings no form of harm to the actual occupants of the building. However, the cadmium metal, when workmen are working with it, it would liberate toxic fumes when the metal is overheated, and this can bring about harmful effects for those who are working with it during processes of smoldering, disassembling, etc. There have been some cases where it has actually led to death. Okay, so what about the health effects of other, what might be considered less tangible materials? But there are other factors we have to consider. So there are health effects of illumination, in other words, lighting. So different levels of lighting are required for different types of work. Poor lighting at work can lead to eye strain, fatigue, headache, stress, and even accidents, because it can affect not only your vision but your focus. Too much light can also cause safety and health problems such as glare. Again, headaches and stress affect your focus, your actual vision. If you're doing precision work, you can make mistakes and that can lead to accidents. Improvements in lighting do not necessarily mean that you need more lights and therefore use more electricity. So, for example, you want to look at things like how do you make better use of the existing lights? Are you using the correct type of lights? For example, in workplaces, we would tend to use white lights because white lights tend to help us focus, help our brains focus better. Um, White lights are not something you would want to use at home or even in your bedroom at home where you would want to relax. Yellow lights or softer lights would tend to be better for those kinds of areas. So you want to place correct types of lights, or you want to make sure that the lights are clean and in good working condition. You want to make sure that they are appropriately placed in the correct positions where the light is most needed. And also, wherever possible, you want to make best use of natural light, because natural light is always better for us in terms of our cognitive functions, etc. What about ventilation? How does building ventilation affect our health? So building ventilation, such as our HVAC system, we know supplies and removes air naturally or mechanically from a particular space, right? Um, the HVAC systems most often consist of the mechanical parts, which should provide air to the building occupants that are at a comfortable temperature and humidity. It must also be free from harmful air pollutants. So those are the purposes of a HVAC system. However, when you have improper operation and maintenance of your HVAC system, it can affect your workplace indoor air quality. For example, the systems need to function to dilute and remove contaminants from areas that are occupied. And some contaminants that can come into your buildings could be carbon dioxide, carbon monoxide, tobacco smoke, even mold and bacteria. Cleaning products, pollution such as ozone pollution from copy machines and printers. Then there's pesticides, vehicle exhaust, all of these things. And some of these sources you probably recognize would actually come from outside. So your HVAC system must always be properly maintained and in good working order. Otherwise, these pollutants in the air would not be removed from the atmosphere, and these can cause um, long-term health effects. So what are some of the symptoms of poor indoor air quality? Dryness and irritation of eyes, nose, throat, and skin, headaches, fatigue, um, shortness of breath, hypersensitivity and allergies, sinus congestion. So we have a lot of respiratory issues, tiredness, dizziness, nausea. And what is important to note here is oftentimes people would generally notice that their symptoms after several hours at work, it would get worse. You know, the longer you stay in the environment, your symptoms would get worse. But you would tend to feel better after you've left the building or once you've had a bit of a break away from the building, such as a weekend away or a vacation time. And these are some of the things that you can observe to know that your health is probably being affected by your building environment. So at this point, I want to thank you for joining me for today's lesson. Please refer to eClassroom for further instructions. Thank you.